We did this this first dot plot in class, in my class, and so I saved this other one for homework. And we're looking at the mother's age. Now we set this up conveniently enough from 3.2 to 3.8. This one here won't work the same way, and I think it's good for you to kind of give a look-see at what you're dealing with. It's also a really good way to organize your data. We saw earlier we had to kind of write out the data again to kind of get it organized. If we just look through and try and decide where we want to start with this thing, looks like 28 might be the lowest number that I can see. It looks like it happens a couple times. And 34, 39, it goes all the way up to 39. So if we start at 28 here, 29, 30, 31, 32, 33. This is the 35, 36, 37, 38, and 39. Perfect. Okay, convenient how that worked out, right? So this is a dot plot, which means we're using dots to represent each of the different individual pieces of data here. Okay, this is the birth weight in kilograms. I don't know why we deal with unit of measures that are not typical to our understanding, but that's okay. Anyway, back to this. So we're going to put a 28, and we're going to put a dot right there at 28. So that represents that first piece of data. And then a 31. And so as you go through this, and I won't necessarily say each number as I do them, but you're basically putting a dot at each location. And what you're seeing right now, and I'll comment on it, before we start building up, this is what's called uniform distribution. You don't have any highs and lows or anything like that. You just have basically about the same all the way across. Now that's going to change starting with that 30 because that's our second 30. So we're starting to stack them now. You got a 31 here, a 32, and then a 33, a second 33, a 29 again, 31, another stack. So as many as you have, you're just going to start stacking them on top of one another until you've got your complete picture here. You may or may not be kind of aware of this distribution, how it's sort of shaping up. For whatever reason, all our data seems to be skewed the same direction. If we had to describe this in terms of the skew, what would skewed right is exactly what we'd probably say. Most of the data is here, and it's kind of pulled this direction. Another term that we'll be referring to shortly is an outlier. We're not going to be too specific about what an outlier is, but an outlier is exactly as it kind of sounds. It lies outside of the regular, the pile of the rest of the data. So skewed right is what we would describe this as, and the best measure of central tendency, this is the third time we've kind of gone back to this, is the median. The median is the best way to describe that. And if we had, I don't know what T is in the alphabet, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So there's 20 pieces of data. If we looked at the middle, the 9th and the 10th, or the 10th and the 11th term, the 10th term is one of the 30s, and the 11th term is 31. So 30.5 would be the median specifically, and it's pretty typical of the data. One might also argue for the mode in this case, because he had two modes that were 29 or 30, but the median is probably the best measure of central tendency there.